An industrial fan does not have one natural price. Two units that look similar can carry different motors, controls, materials, performance obligations, inspection evidence, packaging, and commercial scope. So the useful question is not, what does a fan cost? It is, what exactly is this quotation promising to deliver? In this video, we will build a transparent price map without pretending that every factory, model, or order follows the same percentage formula. Start by freezing the quote coordinate. Record the model and revision, the required airflow and pressure duty point, power supply, control method, environment, quantity, currency, quote date, validity, and exact delivery term and place. If any of those fields move, the price can move for a legitimate reason. A quote without this coordinate is only a number with hidden assumptions, it is not yet a comparable offer. Now open the product architecture. The air-moving assembly includes the impeller and housing, the drive system includes the motor, bearings, and mechanical interfaces, the electrical layer may include a controller, sensors, cables, and protection, and the finish must match corrosion, hygiene, temperature, or outdoor exposure requirements. More visible metal does not automatically mean a higher price, and fewer visible parts do not guarantee a lower one. The cost driver is the specified system, not a photograph. Performance requirements propagate through that system. A harder duty point can change wheel geometry, motor loading, structural stiffness, and the operating range of the controller. Noise limits may require different geometry, speed, isolation, or verification. Temperature, dust, moisture, chemicals, and continuous duty expectations can alter materials, sealing, insulation, coatings, and tests. This is why a price discussion should begin with the application, not with a diameter alone. Quantity changes the manufacturing equation, but not through one universal discount curve. A production run may spread setup, programming, fixtures, documentation, and incoming material handling across more units. At the same time, a larger order can require different lot planning, working capital, storage, inspection sampling, packaging, and delivery scheduling. Ask suppliers to state quantity breaks with the same specification and delivery scope, rather than assuming that every larger batch must fall by the same percentage. Separate recurring unit scope from one-time or project scope. Recurring scope may include the configured fan, standard assembly, routine inspection, agreed packaging, and normal production documentation. Project scope may include tooling, samples, engineering changes, custom fixtures, validation, certification work, special reports, or launch support. These items can be charged separately, amortized, waived under conditions, or handled in another commercial structure. The key is visibility, not a preferred accounting method. Quality evidence is also part of scope. A balancing operation, electrical check, performance test, acoustic test, material record, inspection report, serial traceability, or witnessed acceptance does not mean the same thing unless the method, sampling, acceptance limits, and deliverable are defined. Footage can show that a process exists, it cannot prove the grade, result, throughput, compliance, or cost of a quoted order. Put the required evidence into the request for quotation so every supplier prices the same obligation. Customization creates a propagation path, not just a new label. A voltage change can affect motor selection, controller settings, cables, protection, labels, and test setup. A coating change can affect preparation, masking, curing, inspection, and lead time planning. A connector, mounting, firmware, or packaging change can touch drawings, fixtures, work instructions, samples, and validation. Before negotiating the number, ask which requirement triggered which engineering and production consequence. To compare offers, build a normalization matrix. Hold the model and revision, duty point, electrical configuration, environment, quantity, evidence package, packaging, warranty scope, currency date, and delivery point constant. Mark every line as included, excluded, estimated, buyer supplied, or not applicable. Then place supplier differences beside the changed assumption. This exposes real commercial choices without forcing unlike quotations into a false lowest price ranking. Unit price is not landed cost, and landed cost is not total cost of ownership. Landed cost can add origin handling, freight, insurance, destination charges, duty, tax, and inland delivery according to the contract. Ownership cost can also include installation, controls integration, energy use, maintenance access, spares, downtime risk, documentation, and service support. Do not add invented numbers. Build the stack with your actual route, tariff treatment, operating profile, and service requirements. Good negotiation removes uncertainty or removes a real cost driver. You might freeze the revision, combine forecasted releases, accept a standard connector, simplify a report, align packaging, separate project charges, or offer a clearer delivery schedule. Never delete a required safety, performance, compliance, or quality obligation merely to make the quote look cheaper. Ask the supplier to show what changes when a requirement changes, and keep the comparison coordinate fixed. Here is the complete method. Define the application, freeze the quote coordinate, map the product architecture, separate recurring and project scope, specify the evidence package, normalize every offer, and then evaluate landed and ownership cost. There is no honest universal percentage chart, but there is a repeatable way to make pricing transparent. If you are preparing an industrial fan request, Longwell can help you turn the requirement into a line-by-line quote map before anyone argues about the final number.